Hi, in this video we are going to talk about another implementation of the list interface, the so-called linked list. So this is another implementation of the list interface, but as we have discussed in the theoretical section that it implements other interfaces such as queue and the queue. So we have been discussing that list is a collection and it also implements the iterable interface. And array lists, linked lists, and vectors are the implementation of the list interface. But what's very important that linked list implements the queue interface as well. And because the queue interface extends the queue interface, that's why linked lists implements the queue interface as well. And what's very important that it uses references. We have been talking about array lists and the underlying data structure is a one-dimensional array. Here, the underlying data structure is not an array. Basically, we have the nodes of the list and every node contains a reference or a pointer to a next node. So for example, when we store integers, the 34 knows nothing about -12 or 1. It's just pointing to the next item in the list, which is the 100. The 100 knows nothing about 1, for example, or 34. It's just pointing to the next item. This is the so-called single linked list. But what's very important that in Java, we have the doubly linked list. So every single node has a reference to the next item and the previous item. So we have, for example, 100, then -12, then for example 1, which means that this is the doubly linked list. So instead of pointing to one direction, every single node, okay, except for the first one and the last one, is pointing to the previous node and the next node. But what's very important that these nodes know nothing about the previous nodes and the next node. It knows about the item before that given node and the item after that given node. Okay. So we can come to the conclusion that there is no random access as we have discussed for array lists. If we want to get an item, we have to search sequentially in that given list. It is not synchronized as well, so if multiple threads manipulate the same linked list, we have to make some synchronization. But we can remove items very efficiently. Why? We have been talking about array lists, and if we want to get rid of an item, we have to shift all the items one position up. But linked lists has a different underlying structure. If we get rid of 100, we don't have to shift the item. We just have to tell the previous reference and the next reference to point to each other. So basically we have to manipulate the previous item and the next item, and we just have to update the references, which is going to be very fast. This is why it has order 1, so constant time complexity. So removing an item from a linked list is quite fast, especially when we remove items at the beginning or from the end, because then we don't have to look for that given item. You may pose the question that, okay, first, if we want to get rid of the 100, first we have to find it. And because we do not have random access, we have to consider every single item. Yeah, it is true. But removing item at the beginning of the list, I'm going to write that when removing from the beginning. Okay, or at the end. We know the size of the list, so removing from the beginning or at the end is going to be the same. But because no sequential access, if we want to find an item, we have to iterate through the list until we find it, so that's why looking for an item is not that fast. But a remove operation is very efficient, we just have to update the references and the pointers. So what's the conclusion? That we should use linked lists for remove-heavy applications. We have been talking about array lists. Whenever we add some items to the list and iterate through the list, it's going to be just fine for array lists. But removing is not that efficient for array lists, and that's why linked lists have came to be. We are able to remove items from the list very efficiently because we just have to update the references. So for example, I will have a list of integers. List is equal to a new java.util.linklist. Okay, something like this. Of course, we have to import the java.util.list. And we are able to add some item. If we add some item to a list, for example 3, it's going to be added to the end of the list. So for example, we add 3, then 10, then 20, then the order is going to be, I'm going to print out integers in the list, and let's system out println I. As you may guess, it's going to be 3, 10, and 20. If we want to remove, for example, the first item, so remove the item with 0 index, so the first one, then it's going to be very fast. This is why we like linked lists. Okay, because we can do it extremely fast. We don't have to shift the items after the remove operation. Of course, we are able to get the items. It's going to be true that we can get the item. So if we get the item with the index 1, we can get it, but it's not going to be as fast as we have seen for array lists. Remove, okay, in this case I have got rid of the code snippet where we get item, but we can get item for linked lists and array lists. But this operation is not going to be as efficient for linked lists as for array lists. So basically not that fast. Okay, we are able to get, for example, the list.size again. And if I run it, it's going to return, first of all, 20 is going to be this item because we have removed the first one. And the size is going to be 2 because after the remove operations, there's going to be 2 items in the list. And we can print out whether the list is empty or not. So is empty is going to return false because there are 2 items in the list. So what's very, very important to see that the underlying structure is completely different. We have this pointer and every item in the list pointing to the previous item and the next item. And that's why when we remove something, we just have to manipulate the references. This item is going to point to -12 instead of 100, and -12 is going to be pointing to 34 instead of 100, because Java implements linked list with the help of a doubly linked list implementation. So instead of a single reference, it will have a single reference in one direction and another reference in the opposite direction. So removing items at the beginning of the list is going to be very fast. And why we like array lists? Because we can use random access. Okay, so that's all about array lists and linked lists, the 2 most important implementations of the list interface. Thanks for watching.